All right, we're going to look at Unit 15, Estimating Square Roots. And the first lesson is just going to be what are square roots and then what are some perfect squares that we've seen around our math numbers. So you've got some fill in the blanks on your guided notes, so make sure you're filling those in while I'm reading that. But square roots, what is a square root? A square root of a number is a value that, when multiplied by itself, and so these are the words I'm underlining, you should be filling in, when multiplied by itself gives that number. So any number when multiplied by itself, not multiplied by 2, a lot of students see, 10 squared, and we're going to take that 10 times 2 is 20. No, remember, squaring it is actually creating a square. So if you look at this image over here, you have a 4 by 4. Okay, the square itself is 4 by 4. You look at floor plans, you look at the floor in even your math classes or any class actually, you see those squares and it's a 4 by 4 square, which means then when I take 4 times 4, so my example of 4 times 4, we get 16 because there'd literally be 16 squares in this 4 by 4 square, okay? And so then the square root of 16 is 4. So on your notes, this should be what you're filling out is this example right here, okay? That 4 by 4, 4 times 4 is 16, so the square root of 16, though, is 4. So we know it's maybe something squared is, but the root is then just the opposite of that, is what creates that number, what times what gives us that number. Now, you could also note that a negative 4 times a negative 4 would also be 16. So negative 4 is also the square root of 16 because even if I had a negative 10 squared, well, a negative 10 times a negative 10 would be a positive. So, yes, we can still have negatives involved in those squares and the square root of a number as well. On your notes, you have a little bit of a blank that says the square root symbol like this always means the perfect square root. There's not always perfect ones, but that sign represents a perfect square root. And you see then that it says a perfect square root is a number made by squaring that whole number, the whole number, okay? So here's some examples, all right? And here's a 16, part of your guided notes right here as well. Right here. And it says that 16 is a perfect square because, and that should say 4 squared equals 16. And it's a whole number. It's not a mixed number, it's not a fraction, it's the perfect square because it fits exactly that. It becomes one whole number, not a bunch of decimals or, remainders. So let's go ahead and fill out this first chart just real quick. We're going to identify the first 10 perfect squares. Now, I apologize. My notes are looking funny. So I'm going to zoom out because that should say 1 squared. So on your boxes, you should see something different. So we're going to do the first 10 perfect squares. So you've got 10 different boxes. And that should say 1 squared. What is the perfect square of 1 squared? Well, 1 times 1 is 1. Your next box, we have 2 squared. Notice I didn't do 1.5. That wouldn't be a perfect square. It's got to be that perfect number. No decimals, no fractions. So what's 2 squared? 2 times 2 gives me 4. Next one is 3 squared. Now remember, it's not 3 times 2. It's squaring that number, times it by itself. 3 times 3, we get 9. Then we're going to have 4 squared. And 4 times 4 gives us 16. 5 squared. 5 times 5 gives me 25. So there's your first 5. Let's move on to the next 5. Then I've got 6 squared. 6 times 6 is 36. Then we have 7 squared, and 7 times 7 is 49. Then I have 8 squared, and I get 8 times 8 gives me 64. 9 squared, 9 times 9 gives me 81. And then the last perfect square for our first 10. There's an infinity amount of perfect squares, but we'll stop after the first 10. 10 times 10 gives me 100. So these numbers are our perfect 10 squares. The first 10, I guess I should say, the first 10 perfect squares. Notice there's no decimals, no fractions, or anything listed in those. So now it's time for you to head to your assignment, and you're going to get started and just looking at what are some perfect squares and those square roots of those as well.